5, 6, 7. Oop. Hello everyone. Okay. 1 second. Why it isn't working? Yeah. Streaming here. Okay. So no one asked, no one expected, so this is completely unexpected, unprepared stream, but all my streams always unprepared, so nothing new, nothing unusual. Oh, interesting. I got notifications that I just start this translation. Yeah, I just started this live stream. Okay, never got it before, or maybe I never noticed it. Okay, so why? Just because some smart thoughts occupy my mind and I cannot get rid of them, I decided to run this small stream to try to implement what I'm actually thinking about the last 5 hours. So maybe for last 1 or 2 weeks I closely working with I closely experimenting with Rust async capabilities applied to some high performance environment when you don't want to have this event driven async runtimes with epoll, select and other stuff, when you just want to busy spin and try to continue your async routines if you can. So and I found that all this async stuff, all this future-based stuff in Rust is pretty decent in terms of performance. They introduce really little overhead, and I start thinking, okay, in Rust futures is some sort of coroutines like in C++, right? And C++ coroutines is extremely generic. They support just piece of computation. They also support building generators, right? And stable Rust currently seems doesn't support building generators. So what is generator? I already just opened this unstable page for Rust describing what is generator, but basically it's a state machine which accept some input, possibly empty sequence of input items, and produce output items, right? So I start thinking, what if I don't need this unstable feature? What if I can build it using stable features? So well, of course you can build them manually and provide your custom syntax, but it will be ugly, and no one would like to use it. So what if we can abuse existing capabilities for state machine generation provided for async Rust to build generators? So let's try to do that. So I already set up a small project. So what I want to achieve? Right now on stable Rust you can write async functions, right? Async fn foo, it returns something. Let's say result. E32 and some error, nothing. Async bar fan E32 again, and you can combine them by calling, let's say, okay, 42. And you can combine them bar await, right? And Rust compiler will generate some type. So when we call this, let's go int fn main. Oh, I have a leap. Okay, let's go test. Let's go test. Fn try future. So when we call this mute state machine foo, yeah, without await, Rust compiler generates some unknown object. We cannot name it, but well, we cannot name the type of this object, but it implements future trait, and this object represents some state machine with one single method. This method is where is it? Well, this method, let's go to the future. Yeah, with this one single. Wow. This method. Basically takes this state machine and try to advance it, and it accepts some extra parameter for context needed to actually perform all this delayed invocation in asynchronous times, when it may be some handle to poll context or select context, and your computation can say, okay, call me later when some event happens, and it will call context waker dot wake by ref, or just dot wake to notify asynchronous times that, oh, I'm ready to continue execution. But we can ignore it right now. So this is a state machine with this one method, and we can execute it if you provide some context. How we can provide context? Well, obvious and silly approach. Just take some runtime, like Tokyo, Polster, and some other stuff. But we don't need it. We can just provide our manual context, because we know that this state machine doesn't require any async capabilities. It won't need any interaction with runtime. It just has some suspension points, and we just want to traverse them. Okay, so we can build context. How it can be done? Let context, yes, context. From Waker, yeah, it doesn't have any new methods, but it has from Waker, so we need to build Waker. Can we have some Wakers? Yes, there is some default Wakers, no op Waker. Actually, what we actually need, no op Waker. So now we can go mute, right? State machine, poll, but we cannot poll because poll requires pinning the state machine, because the state machine can be self-referential, it can have some internal buffer and mutate it, so Rust doesn't have any normal and convenient way to express unmovable types, so it's invented this pin annotation for references, that this you cannot move out of this reference, but it's okay, we can just accept it's a syntax exercise we have to do to make borrow checker and Rust type system happy. Okay, let's do that. We need to pin it. Let mute state machine std pin state machine. Ouch. State machines here. Actually, mutable is not needed here. Let's go. And now we can start executing it. So state machine, poll, and provide context. Not context. Right? Right. So we write something like this. Let result here we write some loop. Bim, bim, bim. Let poll ready. Else continue. Break result. Alright, oh, we need to import std task pool, but that's all. We can run it. We can write print ln bold. Oh, sorry, not here. Here. And we can print ln result as well. Result. Let's go. See? Boom. A lot of stuff. I have criterion dependency added to this project because after we finish, I want to benchmark this stuff. That's why there is a lot of dependencies. Of course, if we just use std future, there won't be all this nonsense here. Okay. Boom. Okay, what we have here cannot compile right because we need to borrow it again as mute. That's fine. Let's try again. Yeah. So it's polled one times and immediately returned result. Nice. But we can provide some actual suspension point because right now all these functions immediately return results. But we can have suspension points. Let's do that easily. It can be done. Let's do something like this. Struct suspend. Here we need some bool. And implementation impl future for suspend fn poll, and we can do following. If how it can be done easily. Yeah, let's do this. Std mem. So if it's a first invocation of poll for this suspend element, we need to return pending. If it's the second invocation, we need to return done. Std mem swap. Sorry, replace mute self 0 true. So bool indicates if it's the first invocation or the second invocation. If this, we return Paul ready. Okay, we also need to provide type, output, nothing. Else Paul pending. What's wrong with you? Yeah. No. And again, we don't need anything from context. We don't need even to wake this. We don't need even to use this waker stuff, because okay, as I said initially at the beginning, we are not going to use all this heavyweight async runtimes which reacts on event reacts for events. We are going to busy spin and call Paul again and again and again. But all entire purpose of this waker is to notify runtime that you need to poll this future, but we are going to poll it anyway. So that's why I'm not going to use a waker. But okay, of course, if this future built for general purpose runtime, I have to do something like this. Text waker wake by ref. Yeah, but I don't need it. Let's try again with this stuff. Yeah, and I need to provide some method for convenience. Fn, async fn, not async, fn, const fn, suspend, return impl future, output this, and return what? Suspend false. So now if I start using it in, let's say, foo and bar, so if I do it here, suspend, await, boom, suspend, now our loop should perform 3 iterations. Let's check it. One, two, three. It works. So okay, now how we can make it a generator? So okay, to recap, what is a generator? Generator is a similar state machine, but on each suspension point it can return some value. So for example, if we go for Python, right? For Python we can write some kind of generators. Let's try a new text file. Genpoo. Let me recall how generators can be written in Python. Def my generator, let's say some parameter n, and I do something like this for I in range 0 n, we yield I square, right? So now I can write something like this. Python state machine, my generator, let's say 5, and I can call next. Or I can just use for-based loop, range-based loop with it. But print, this should be more straightforward to show. What is it? State state machine next, I guess. This method. Let's try. Ouch. Python 3 GenPy. Let's go. Okay. Sorry. Move here. Right. Bam, bam, bam. One. Yeah, it works. So it's essentially the same. But instead of poll, we have next method. And also this generators in Python, similar how it works in C++ and proposed Rust nightly feature, they also accept input parameters in all these next methods. So we can return some value from yield. So here can be x yield, and we can print it. Print x. I'm not sure how exactly it can be passed, but let's see. Hello. Nope. Let me check documentation. Python, how to pass value back to yield using send. How it works? Okay, generator has send method. Okay. So here. So state machine has send method. Let's try. But it's comment for Python 2.7. I'm not sure if it works for. Cannot send. Now it works. Yeah, nice stuff. So we want to have something similar in Rust. And this nightly feature actually provides that. We have resume, similar to it's a combination of this next and send. In second parameter, we provide the value which we want to return to the generator, values that will be returned from the yield, and everything else similar to the features. So we technically can't do that because we have context, right? Context is generic, we can pass everything. Pass anything here. Let's try that. Okay. Let's try to build something similar. So this suspend will be yield. But yield is already reserved word. We need a keyword. We need to invent something similar, something different. Okay, let's make it yield now. Okay, let's start with simple stuff without returning values. Just without returning values from yield, just return sequences from generator. Oh, how we can do that? Okay, let's build some stuff here. Struct yield now. It needs our input parameters that we're going to return. Boom. And how we are going to return it? I don't know. Option mostly. Option T. And now let's try to implement it. Boom. Impel future for yield now T arbitrary T type output. Right now I don't care, it's just nothing. We are not going to return anything from this yield to the state machine. We are going to return it to the color side. Fn poll. And now the fun stuff starting here. So of course, first of all, we are going to take what we are going to take. Oh, we are going to have some pain with all this pinned shit in Rust, but no problem. So first of all, we're going to take out the value. Let value generated value. Okay, let's do it's in like different way. Let's put to do here, and let's try to write this stuff somewhere. Let's say we will have where is it? Let's provide some function fn yield now const return impel future yield now, and here we need a parameter to return t. T impel future output nothing, and return yield now some value. So we now can write some generator. Let's go async fn my generator and use size return nothing, but for x in 0 to n we want to return yield now x squared. Oh wait, cool. So now okay, to do will fail. Let's return something. Poll, let's say ready, just as a stop. So now we want to achieve something like this. Hop. Try generator. Use this my generator 5 state machine blah blah blah. Let's start polling it, and we want to get result. The only way to get result of each iteration is to potentially ask if something new is in context. So here we going to inspect context to retrieve result. Nice, nice. And this yield now need to put something into context. But to be able to do that, we need to reserve some buffer inside this context, because right now we use some standard provided, STD provided no operational waker, no operational context, and we cannot do anything with it. We need to provide our own context, our own waker. Let's do that. Actually, if we go to, let me open it, Fuchsia Rust. If we go to context itself, let's go here. Open. Here it has again unstable method extension, which actually can provide access to some arbitrary value inside context. But it's again unstable feature. Let's build our own stuff, because the only thing that we have right now unstable is implementation of waker. We can implement our own waker by providing raw waker, some raw unsafe stuff. Let's do that. Yeah, there is new. We can provide arbitrary data. We can provide arbitrary callbacks to it. Let's do that. Let's do that. So we need some waker. Okay. Wach. We need static rough my waker table. It's a rough waker table. Waker table, and what we need to provide here: clone, wake by ref and drop. But nice, thank you for watching. We need to provide all these methods, but we're not going to use any of these methods. So we're going to provide just stubs which does nothing. Okay, let's go. Clone. Wait, maybe not just does nothing. They should panic if anyone tried to call them for safety. It will be completely safe. You know that this generator wrapper can be used only in your particular runtime, so no one else should use it. Otherwise, just crash them. Raw waker, so clone. We are going to panic. This waker is not suitable for general purpose. times. Okay, next we need what other methods we need? Wake. Again, same stuff. It again does nothing. It consumes semantic. It has consumed semantic. Let's go here. Boom. Wake again. Wake by ref. You know the drill, same. Same stuff. Again, panic. Boom. And only drop, we have to provide it. Drop. But we don't need to do anything. Just std mem drop. Ignore this pointer. Oi, why? What's going on? What's wrong? Field is private. Why? Oh, new. Okay. That's strange. Why? Why they did it like this? Okay. Wake by ref. Wake. That's all? Okay, nice. We have the table. Now we can start providing our wakers. Ooh. So, but we are not going to do that. We are not going to provide this waker. We are going to provide generator trait. Pop. We need this pop trait. Generator. So type yield, type return, right? And we need this method resume. Right now we are not going to provide any special inputs for the state machine, just let's get output. So we need here some output structure, struct output, okay, generator result, yield result, not struct, it's enum, right? Enum yield return yield and return. Here we have this pin self mute self and return generator result. Generator result self yield self return. So now let's implement it for futures. Yeah, type, not type, let's have some struct future again. Here inside we have future. I don't want to implement it for all futures because we will see that there is safety considerations that again this context doesn't carry information about which value can be yield. So technically I can write something like this. Let me show you. So I can write yield now hello. Yeah, this one. And it will compile, but this is definitely not correct stuff because a generator should generate only, well, generator in Rust. In Python it can do anything because Python is dynamically typed. In Rust, generator should, not just should, it must produce the sequence of values of the same type, same type. And here I produce values of different types, and there is no way for me to encode this restriction. That's why we actually need this unstable nightly future if we want to encode this restriction. But if we don't want to encode this restriction, that's fine. We can live without it. So this is a problem. We can assert it only in runtime, unfortunately. Only in runtime. Okay. And also we cannot do, I mean, we cannot insert it for all types. There will be some problems, but let's face these problems later. Let's go naive way and implement it as we can. We can do anything. So here it's future. F. Most likely constructor should be unsafe because of this stuff which I already just mentioned. But that's fine. That's fine. Let's go and implement generator for it. Impl generator for future again. F future. Here we need to say exactly here we need to say exactly which sequence we are returning. So here I have to add some yield value and have phantom data for it, because future have only output. Future has only output type, but we need also this extra yield type. Okay, so generator for future again. Y. And now let's go. So type yield y, type return is future output. Makes sense. Fn resume. And now let's craft our context. So I'm going to put output into what? I don't know. We are going to have, well, because there's a const pointer, I need to operate some types with Interior mutability, so it will be cell. Let output, yield value is cell new none. I need to specify types. Unfortunately, cell option Y, maybe something like this. And I need to provide some, let's go. Eventually there will be another episode of podcast. Yeah, we are slowly preparing next one. Slowly. No guarantees, but eventually everything happens. Everything can be here. Wait. I need something like this. I need another structure. Struct yield placeholder. Let's make it like this. Cell option T. Quick fix. Import, please. Import. Yes. Default can be. No, default cannot be inferred here because default is stupid. In terms of generic impl default for yield placeholder blah blah blah. Fn default cell default, and here it will work. Okay, now I can do yield placeholder y new default, sorry, default assignment, please. I need some unsafe method. Yeah. Unsafe fn yield value t. Here I accept context. Mute context. I don't care here about this parameter. I have here the value t, and how it will work. We are going to take context waker data, and I say that this data is must be yield placeholder for this t. I cannot guarantee that, but it must be yield placeholder. So it's data, we go to cast it. Cast, it's a pointer, yield placeholder t, nice. Let placeholder dereference yes, unsafe, more unsafe. Nice. And we need some methods. Fn set yield value self value t. We are going to do that self 0 set some value. Nice. What's wrong? Okay, I'm implementing this method in the wrong place. Impl t yield placeholder t. Bam. Cool. So I do placeholder yield value. Okay. Okay, what we can, how we can assert it? Is there any way to assert it? To assert that we have a right type. I don't know. Maybe. It might be possible if Rust had generic static variables, but it doesn't. But we can try. We can try, and then Rust will say that I cannot use generics in static variables. But let's try. Let's ensure that we have a problem. Fn fn raw make raw table. We need some t parameter, and it must return static raw waker with table. So if we do something like this, it won't compile, unfortunately. Okay, static with table raw waker with table. Raw waker with table. Put all this stuff here. Sorry. New. Put all this stuff here. With one extra modification. Let's say here. Here some pointer, right? ptr const this to try to capture this generic parameter. I perform ptr cast, but it won't work. ptr cast t. Okay, what we have? And says can't use generic parameters from outer item, blah 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 blah. Yeah. Unfortunately. But that's okay. That's okay. That's okay. Boom. So this won't work, unfortunately. But let's continue with some safe stuff. That's fine. We'll just mark something that this is unsafe, and that's fine. This creation of future gen wrapper will be unsafe. That's all. That's all we need. Okay. Return. Okay, so we have this. We build Waker. Let Waker raw Waker. How it's done? Raw Waker. New. We take this raw const. That's const yield value cast to some universal pointer. So I just took the pointer instead of reference, and now cast it to what it requires. With table we have it. Let's put it my Waker with table. Boom. Now create not a raw Waker, normal Waker. So Waker from row. Now it's unsafe. Raw Waker. More unsafety. Unsafe. Unsafe. We have Waker. Nice. Now we can finally create context. Context. From Waker. Yeah. And now we can finally poll this stuff. Let's go. Self 0. Okay, we need project. Self pin reference. Such a wonderful stuff. Self, how it works. Map unchecked mute. What it must return. Yeah, mute here. Mute. Again unsafe, more unsafety. What's wrong with you? Okay. Then we call poll. Mute context. Boom. Result. Now we can match it. Pull result. So if it's ready, nothing to do, return it. Generate our result, return X. Otherwise, poll pending. We need to extract value from yield from placeholder, right? Okay. Fn take value. T self 0 take. It returns optional. Unwrap. Expect. If generator is suspended, it must yield something. Okay, let's go, let's take it. Yield value, take value, generator result, yield, right? Boom, boom, boom. Nice. Okay, now the only one step missing is to what? Why it's red? What's red? Self. Okay. Okay. This. This. So now the only missing part is actually to implement this yield now. Yield now, where is it? Yield now. Yield now. We go here and do following. Context. So we do following stuff. Self get unchecked mute. That's fine. This. Sorry. This 0 take. Ну и тут and here we have. If we have something to yield, we need to yield. Otherwise, we are done. Oh, I can do better. Let some value else ready. Return it. Otherwise, context yield value, context value more unsafety, unsafe. Boom. And here Paul pending. Okay. Now let's try. It seems that's all what we need. So let's go here. We have our generator. Where is it? Where is my generator? Generator. Yes, this one. My generator. Let's go with it. So here, instead of using the future trade, we need our generator. We don't need context here anymore. So let generator, future generator. Well, first of all, let's provide fn how it's better to okay, yeah, fn unsafe fn generator to generator. Here must be some parameter y, and here we accept the future f impl future output nothing. Oh, sorry, just simple future. We don't care here. Return future again. We can. That's fine. Impl future y. Future again. Phantom data. So unsafe to generator state machine. Boom. Again, we have to pin it and just start resume. Boom. Here we have to match it. Match result. Match result. Generator result. Yield x. Let's print it. Print ln x. We haven't specified exact type. What's the type? I don't know. I don't know which type here. Where is it? Where is it? Where is it? Where is it? It's usize. So, okay. It's obviously why it's unsafe. It's completely unsafe stuff. Because here I must to manually provide exactly the same type, and it cannot be asserted. in runtime. Oh, not even, well, it cannot be asserted in compile time. It cannot be asserted normally in runtime. Use size. Generator use size, resume. Generator result return, don't care here. Break. Now we don't have any results. Boom. Boom. Yep. And if everything is done correctly, it will work. Let's go. Yep. Our generator just generated our sequence of squares. Let me move it closely to my test. So the only thing here is to maybe provide some prots macro that can assert it statically. But basically, yeah, we just implemented generator. At least that part which doesn't return any values back to the generator, but we can provide such support as well. it will have more safety. It will have more and more safety in it. Let's try to do that. So now we want to have here the resume parameter, right? R value, and this value will be returned back to the to the generator. How can it be done? How can it be done normally? Again via context, right? So now in this yield, now we have two values. Ooh. R. Option R. Okay. R. Output now it's R. So in context there will be a value. Oh, so stop. We don't need it here, right? We don't need it here. Yeah, we don't need it here. We need phantom data here. Phantom data R. So here, when we're ready, we need to take this value back from context. So now in context, there should be 2. Or we have to insert it. We have to insert it because it will be from the next iteration, right? So what's the flow here? Here we have this parameter r. Resume well is r. We insert it into context. We insert it into context. And future must take it, I guess. Because next resume will be the next with different value, so we have to insert it. Yep, no problem. Go into this yield placeholder. Here provide another value. Cell option T, option R. Now we don't have default anymore. When new XR, we return self here, self default here, cell new sum x. So yield value. We need another method, fn take resume value self t r self self is 1 take unwrap expect resume value must be taken only once. Nice. So now we can implement this stuff. I have to store some value here. Instead of phantom data option R. So if I have nothing to yield, here, 1 second. So yeah, here I need to yield value and I need here unsafe which is this yield value can immediately return the stored value, right? Right. Assume value. Let yield value tr return r. Okay, and here we do r. Let's do this. Yep. This has more sense for me, actually. Oh, and we probably can do it even better. Maybe something like this. Enum yield state resume t resume r and yield t. What if we do something like this instead? Insert here cell of this stuff. Boom. Cell yield state tr. Boom. Cell new yield state resume x. Yield value, we go here and replace with yield state yield value. Let yield state resume else panic already yielded. I don't know what's the right English word here, but I don't care. And here there will be not this, this. How it's done? Self not let yield state yield x self 0 else panic not yielded. X. Upsell into inner. Okay, and let's fix all this stuff here. Yeah, Rust creates language for writing all this state machine stuff. So here put R, not default but new, resume value, insert. Yeah. So now we can go here. And again, instead of this option, we can have here yield state tr, and now everything's much better, or not. Let me think about it. Yeah, I have to provide some optionality. Unfortunately, some optionality should be here. How to do that? Seems like this option. So I do check let much self 0 if it's yield state resume R, then we return poll ready R take and expect. Not ready yet. Otherwise, it's yield state yield how to do that? Yeah, 1 second. I'm slightly wrong. E flat. E flat. State. Resume. If we are resume state, then return this. Otherwise, what we can do? Otherwise, we need to do std mem replace byte 0. This. Move this 0 with yield state resume none. Let yield state yield x else panic incorrect state then we yielded value we obtained the new resume value, inserted, replace mute this with yield state resume some resume value. Nice. This 0. And pending. Nice. Format, please. So yield here we have R yield now yield state yield value. And here we have this ugly syntax. Like this. Resume boom. Let's test. Still works. And now let's communicate back with generator. I don't know. Let's put some hello world. It's completely unsafe again. Here no any mention of lifetimes again also. So it's unsafe in multiple direction, in multiple meaning. Let's print ln s from generator. And also, unlike Python generator, when we cannot provide value before first poll invocation, here we can provide it. Let's go. Try generator. What we have? So it's fault. Then return from hello world. Yeah, that works. We can return some non-static value. Let's see. Resume. Let's see. Let's mute iteration. Oh, we can write something like this, right? For iter in 0 blah blah. Resume format hello iter and again here I have to update type string now, otherwise it will seek fault most likely. Let's see what we have here. Yep, it works. Not sure if it works as expected for nightly version, but yeah, it works. So now if we can provide some nice proc macro around this unsafe stuff and actual function. Where is it? This one. So mark it here. Let's say something generator. Yeah. So if we can provide some such proc macro which will assert types, that all types used here the same across all yield invocation, all types passed to the yield now function also the same. It can be useful. It can be usable. Otherwise, it has too much unsafe edge cases. Yeah. But it works. We don't need nightly features. Yeah, we just can go unsafe YOLO mode and implement generators with async support in futures, with futures. Nice. Yeah, that's all for today. I believe, yeah, it's 10 o'clock. Yeah, almost 10 p.m. So I finish with it. I'm finishing. Can we do slightly better here? Probably no. Probably no. Here theoretically you can do slightly better than this, but let's see. This is still good enough. Yeah, that's all. Enough for today. Thanks for watching. Thanks for joining this. No idea if anything were clear or not. I got some fun. Maybe you too. Thank you. Bye. Bye.